Hi students, so today we're going to go back over expanding brackets and factorising. As you know, your test is next week and this is something that will be on that test. So it is going to be worth your time to watch this video, and if you need to watch it again, as always, I encourage you to watch it as many times as necessary. Anyway, let's get into it. Let's start with expanding brackets. So the distributive law is the name given to the process of expanding brackets in an algebraic expression. Now, we learnt this the other week, so I'm hoping that you remember that. So because of this law, for this example here, let's do 3 times 5 plus 8. Because of this law, the number in front is distributed to each of the terms in the brackets. So 3 times 5 plus 8 is going to be the same as or equal to 3 times 5 plus 3 times 8. Now we could go and put brackets around those, but we don't really need to, because we know that with order of operations we need to do the multiplication before the addition anyway. And because in algebra a variable or a letter will obviously take the place of some numbers, this law also holds true for algebraic expressions. So let's do an algebraic one. For example, a times b plus c is the same as ab plus ac. Remembering that this here basically means a times b plus a times c. Remember that we don't actually need to have the multiplication sign between the variables when we are doing algebra. All right, let's try one that has got both numbers and variables in it. Let's go. Oops. 3 times a plus b. All right, we're going to expand this. We're going to expand this out now. So 3a plus b, 3 times a plus b equals 3a plus 3b. Remember that when a number and a letter are next to each other like this, it means multiply. So this is 3 times a. Here we've got 3 times a. This is 3 times b, 3 times b. Now, an expression like this can be written in expanded form or in factorized form. So if we wanted to expand this here, this is our expanded form. We've expanded the brackets. This over here is factorized form. They are just the opposite of each other. So factorized and expanded. So if you are given this one and they ask you to expand it out, they want you to do this. However, if they give you this one here and they ask you to factorize it, they want you to do this. Just a quick side note that the distributive law is not used when the terms inside the brackets are multiplied or divided, only when they are added or subtracted. So for example, when we are given 2 times 4 times 5, this actually equals 2 times 4 times 5. All right, we are not going to expand it out, so we are not going to do this here. 2 times 4 times 5 does not equal 2 times 4 times 2 times 5. All right, so this, yes. This one here, no. All right, we only use it when we are adding or subtracting. All right, adding and subtracting only. Multiply and divide, no. All right, let's do another example. Let's do 3 times a plus 2. All right, we know that we can do this. If you need to draw this out this way, then you are most welcome to. We can use arrows. We need to do 3 times a and 3 times 2. All right, so it equals 3 times a plus 3 times 2. Now, 3 times a is just 3a, and 3 times 2 is 6. We can't go any further with that, so that is our answer in expanded form. Let's do a slightly trickier one. X times x minus 5. All right, we need to expand it out. All right, so we've got x times x. And remember, just because it has nothing in the front of it here, just because there's nothing there, doesn't mean that it's 0. It is 1x. X is the same as 1x. All right, now we need to expand out over here. So x times x plus x times negative 5. Remember, we've got our negative sign over here. All right, let's do this one here first. So 1x times 1x equals x squared. All right, and now we're going to do this bit here. X times negative 5. So a negative and a positive multiplied together is going to give us a negative. So let's put in here a negative 5x. We can't do anything further. That's expanded as far as it can go. Let's move on to factorising now. So factorising is just the opposite to expanding, as I explained just before. It involves identifying the highest common factors of an algebraic term. And in order to do this, we need to take the following steps. Firstly, we need to find the highest common factor of the number parts. So when we have an equation with numbers and variables, this step is only looking at the actual numbers. Number 2, we need to find the highest common factor of the variable parts. So number 1 is the number parts. Step 2 is to find the highest common factor in the variable parts. And lastly, step 3 is to multiply these together. Now that all seems pretty confusing, but let's do some examples together and you will see that it's actually not that hard. All right, let us find the highest common factor of 6x and 10. All right, so we need to find the highest common factor of the number bits first. So let's break 6 here down into factors. What times what equals 6? Well, we know that 3 times 2 equals 6. Now let's break down 10. What times what equals 10? Well, we know that 5 times 2 equals 10. Now, what can you see that is the same in both of these? That's right, the number 2. Both of them have 2 as a common factor. So we can say that our highest common factor of 6 and 10 is 2. Now, what about this? Well, there's only x on the one side. There's only an x here. There's no x with the 10. So we can therefore say that the highest common factor of 6x and 10 is 2. And that is all there is to it, really. All right, here is another example. We want to find the highest common factor of 14fg and 21gh. Now we've got a few extra variables in here to make it a bit trickier. So first of all, we need to look at our numbers. Remember, that is our first step. We're looking at 14 and 21. What are the factors of 14? We know that 14 is the same as 7 times 2. And our factors of 21, what are our factors of 21? That's right, 7 times 3. And in here, we need to look into finding which one is our common factor. That's right, 7 is our common factor. So we can say here that our highest common number factor equals 7. Now let's look at our variables. So we've got f and g over here, and g and h. So we know that f and g is the same as f times g, and gh is the same as g times h. Now, which one of these is a common variable? Yep, g. Both of them have g in it. So our highest common variable factor is g. All right, we found our number highest common factor, and we found our variable highest common factor. All that's left to do now is our third step, which is to multiply these two together. All right, and 7 times g is the same as or equal to 7g. So our highest common factor for 14g and 21gh equals 7g. So sometimes, instead of just finding the highest common factor of some terms, we'll be asked to actually factorize an expression. And in order to do this, we place our highest common factor of the terms on the outside of the brackets, and the remaining factors that are left over for each term inside the brackets. Again, this sounds confusing, but let's do an example and you see that it's actually not that confusing. So let's say we want to factorize 2x plus 6. All right, we know that 2x is the same as 2 times x. Okay, and 6 can be brought down to its common factors of 3 times 2. Okay, now what is our common factor in this? 2. They are both the same. All right, so 2 needs to be put on the outside of our brackets. So it'll be 2 times what's left, x plus 3. Now in algebra, we don't really need to use this on the outside of a bracket. We can actually just write our answer as 2x plus 3. All right, let's move on and do another example. All right, let's factorize 12gh minus 8g. We need to break down each term into its factors. So we know that the factors for 12 are 4 and 3. And our factors for GH are G and H. All right, now let's do the other one. Let's do this one over here. Okay, so now we subtract. We know that the factors of 8 are 4 times 2, and we've got our G there, so times G. All right, let's circle our common number factors here. There are 2 4s, okay, and our common letter factors or variable factors are G. There's 2 G's. There's no more 3s, no more H's, and no more 2s. So we know that 4 and G are our common factors. So let's write our common factors on the outside of the brackets first. So 4 times G times, and we put the rest into brackets. So we've got 3 times H minus 2. All right, now we don't need this sign here. We don't need this sign here. So let's simplify it a little bit. 4G, 3 times H minus 2. And I've just noticed that we also don't need this sign in here, because when we have our number next to a variable for multiplication, we can actually get rid of this altogether. So we've got 4G times 3H minus 2. And we have now factorized our original question.